Okay, so this is the third lesson in the binomial expansions topic, and we're going to concentrate this time on how we can apply what we've done in the binomial expansions to working with partial fractions. We looked at partial fractions in chapter 1 of the year 13 book, so you should already be familiar with partial fractions. If you're not, you might want to make sure you go back and look at that before you look at this video, and make sure that you are happy with splitting fractions into partial fractions. So I've got an example as a kind of a reminder. You might want to skip this if you already can remember how to do partial fractions, or you might want to pause the video and check you can do partial fractions. See if you agree with me. So I'm going to go straight in and just split this. This is going to split into something over 1 plus x plus something else over 2 minus x. I'm going to multiply by the denominator on the left and get a bracket 2 minus x plus b bracket 1 plus x. I'm going to let x equal 2, which will on the left hand side give me 4 minus 10, which is negative 2, and on the right hand side the a is going to disappear because we're timesing it by 0, and b is going to be 3. Okay, I've already made a mistake. I've just said that 4 minus 10 is minus 2, which it isn't. 4 minus 10 is negative 6. That will make this much easier because b is now negative 2 and not a decimal or fraction. Carrying on, if we let x equal negative 1, I'm going to have 4 plus 5 on the left hand side, which is 9, and on the right hand side I'm going to have a times 2 minus minus 1, which is 3. So a is positive 3, which means 4 minus 5x over whatever it was, 1 plus x, 2 minus x is the same as 3 over 1 plus x minus 2 over 2 minus x. Right, so why have I gone back over this? Well, I've gone back over this because these are able to be written as binomial expansions. I can rewrite this as 3 lots of 1 plus x to the minus 1 minus 2 times 2 minus x to the minus 1. And this is in our binomial approximation form to apply the formula. And this is something we might have to do in our exams. So we might have to do the partial fractions first, followed by binomial expansion. So if we take the question from the previous page and apply a binomial expansion question to it, we've already done half of the work because we've already split it into the partial fractions. So we're not going to expand this, we're not going to find the binomial expansion of this, we're going to find the binomial expansion of the split version, which is 3, well, I've already written it out in negative power form. So we've got 2 questions in one. We've got to do this one and then this one. So if we deal with the 3 bracket 1 plus x to the minus 1 first, this is all ready to go. This has got a 1 at the front, which is what we want. So we are going to leave the 3 there, and we need to go up to x cubed. Yeah, up to x cubed. So that's going to be 1 plus minus 1 times x plus minus 1 times minus 2 times x squared over 2 plus minus 1 times minus 2 times minus 3 times x cubed over 3 times 2. That's 1 minus x. Those 2's are going to cancel. Those negative signs are going to cancel, so it's a positive term, and it's going to be x squared. On the fourth term, that 3 is going to go, that 2 is going to go. We've got 1, 2, 3 negative signs, so that's going to be negative x cubed. And if we times it by the 3, we're going to get 3 minus 3x plus 3x squared minus 3x cubed. We need to deal with the negative 2 over 2 minus x. Now I've gone back into fractional form. This is a little trick that you can do to avoid this annoying negative, because it's going to be annoying to have to subtract something from here. I'd rather add, so I'm going to change this. I'm going to times top and bottom by minus 1 and get 2. No I'm not. I'm going to leave it. I'm going to leave it as a negative. But what I am going to do is I'm going to divide top and bottom by 2. And the reason I'm going to divide top and bottom by 2 is because it's going to simplify this to a 1. So I don't need to do that step that we have to do in the lesson 2 work in 4b. I can say this is the same as negative 1 plus x. Sorry, 1 minus x over 2 to the minus 1. I've got my minus 1 here. So I just need to times each term by minus 1. And then add them together. Okay? So you could just ignore this and subtract, or you can keep it in and add. Don't do both, because that will cancel it out. So I'm going to get rid of it and remember to subtract. I'll remind myself, I'll write a little note. So let's just work out 1 minus x over 2 to the minus 1. That's going to be, we need to go up to x cubed. That's going to be 1 plus minus 1 times the x term plus minus 1 times minus 2 times the x term squared over 2 plus minus 1 times minus 2 times minus 3 times minus x over 2 cubed over 3 times 2. That is 1 plus x over 2. It is going to be plus, they're going to go, x squared over 2 squared is 4. The next term is going to be positive as well. That 3 is going to cancel and that 2 is going to cancel, and I've got to remember to do 2 cubed. That's going to be x cubed over 8. So we've got our first term, our first expansion. That's 3 minus 3x plus 3x squared minus 3x cubed, and we need to remember to subtract all of this. So that's going to be a minus 1, a minus x over 2, minus x squared over 4, and minus x cubed over 8. And that is going to give us 2 minus 3.5x, so that's minus 7 over 2x, 2 3/4 x squared which is, as a top-heavy fraction, 11 quarters. And minus 3 1/8 x cubed, and as a top-heavy fraction, that is 25 x cubed over 8. Okay, so that is my answer. That's quite a difficult question. There was a lot of steps involved there. I had to do 2 binomial expansions. We would have to do the splitting of the partial fractions first. We also need to do this last line, state the range of values for which the expansion is valid, which can also complicate things because I've got 2 expansions. So which one do I go for? Do I go for this one or do I go for this one? You always go for the one that is the most restrictive. So if I've got a choice between -1 and 1 and between -5 and 5, I'm going to go for the -1 and 1 because it's always valid then. Whereas there's no point in the -5 and 5 one being used when that's only valid for half of the question. It's going to mess the whole thing up if you use a 4 because it's not valid for the first part. So we've got -1 and 1 from this one, and for this one we've got between -2 and 2, which means the expansion is valid between -1 and 1. Not the, oh wait, no, yeah. It was -2 and 2. Okay, so we're going to go through one more example just to check that you are happy with how to do these types of questions, and then you are able to work through exercise 4C, and you are able to go through all the mixed exercise for chapter 4. So this is kind of a check if you understand what's going on. Full question: do the partial fractions split and then look at the binomial expansion. We're only going up to x squared because there's quite a lot of work involved. Notice I've also snuck in a repeated root. So can you remember how to deal with those? Again, pause the video, have a go. You might want to stop halfway and check you've got your partial fractions split correct before you carry on doing the binomial expansion, because you don't want to make a mistake on the split and then do the expansion all wrong. Right, so 3x squared plus 8x minus 1 over x minus 2 x plus 1 squared can be written as a over x minus 2 plus b over x plus 1 plus c over x plus 1 squared. I'm going to times by the denominator on the left and get a x plus 1 squared. I'm going to get b times x minus 2 and x plus 1, and I'm going to get c times x minus 2. I'm going to let x equal minus 1. On the left hand side, I'm going to use the calculator for this. I'm going to get minus 6. On the right hand side, the a term's going to go, the b term's going to go. I'm going to get c out of this one, and that's going to be minus 3. So c is positive 2. When x is 2, the left hand side is 27, and the right hand side, this is going to get me a is 3 squared, which is 9, so a is 3. And then there's nothing else I can choose for x to make a and c disappear but keep b, so I'm going to just let x equal 0, which will give me minus 1 on the left, and on the right it's going to give me A lots, which is 3 lots of 1 squared, which is just 1, so 3 times 1. The B term is what we're interested in. I don't know what B is yet. Is going to be minus 2 times positive 1. And the C term I do know is 2, and that's going to be times by minus 2. So minus 1 equals 3 minus 2b minus 4. That is going to be minus 1 equals, if I bring the 3 and the minus 4 together, that's minus 1 minus 2b. I'm going to add this to the left, and I've got b is 0. That's okay. Sometimes b is 0. I wouldn't be surprised if b ends up being 0, because they're helping you. They're simplifying, they're making less work for you to do. I wouldn't have been too impressed if I had to do 3 binomial expansions. So that's not a big surprise that this middle term's disappeared. A and C can add together to give you that common denominator. You don't always have a B term in this kind of question. So what that means is that this expansion can be written as 3 over x minus 2 plus 2 over x plus 1 squared. So we're going to take that and we are going to do the binomial expansion of this, the binomial expansion of this, and then add them together. So that's the next step, that's the next stage. So I'm just going to draw a line under here to show that we are entering kind of the next phase of the work. We've got 3 over, what was it? 3 over x minus 2 to work with. Let's do that bit next. I'm going to rewrite 3 over x minus 2 as 3 times x minus 2 to the minus 1. I can't expand this yet. This is not in the right form. In fact, I'm going to go back a step. This is the easiest way to deal with the terms when x is at the front. We need the x to be at the end. We need it to be 1 plus x to power something. So the easiest way to deal with that is to times top and bottom by minus 1, because that will allow you to switch. No, I've written that wrong. That should be minus x plus 2. It will allow you to switch the bottom two terms to 2 minus x. Then I'm going to divide top and bottom by 2, which you might think is a bit odd, but you'll see why in a minute. Because what I can now do is bring this up as a negative 1 power. And now it's ready to go. So even though the term on the very left looks different to the term on the very right, they are the same. It's just now in a form that I can work with. Remember, we're only going up to x squared. So I'll leave the minus 3 over 2 at the side for now. First term's 1. Second term is going to be minus 1 for the n times the x term. And I only need one more. Minus 1 times minus 2 times the x term squared divided by 2. This is going to be a plus x over 2. This term, the 2's are going to cancel. It is going to be positive because this is going to square, and then I've got 2 more. X squared over 4. and then bring in the minus 3 over 2. Okay, so that's dealt with. Let's put another line and bring in the next expansion that we need, which is 2 over 1 plus x squared. Well, it was written x plus 1 squared. I changed it in my head already, didn't I? I can switch these around straight away. Which means it's already in the right form for me to bring up to the top as a negative 2 power. So that's actually easier to turn into something that we can work with. So let's go ahead and do this expansion. As always, I'm going to leave the 2 at the front. 1 plus n x plus n minus 1 x squared over 2. That's 1 minus 2x. What's going to cancel? The 2 2's, and this term will be positive 3x squared. Times in the 2 in, that's going to be 2 minus 4x plus 6x squared. And we were adding these terms together. So I need, where has it gone? I need this, and I need this, and I need to add them. So we are going to have that's minus 1.5 add 2, so that's positive 1/2. Minus 3/4 minus 4 whole ones is minus 19 over 4x, and minus 3/8 plus 6 is positive 45x squared over 8. Okay, so I think we've answered everything we need to. It's always worth going back to check you've answered the question fully. I've checked that I've gone up to x squared, which I have. It's not asked for which values the expansion is valid for, so I don't need to worry about that on this question. So that's the end. So you should now hopefully be able to work through exercise 4C, which is on page 102, and you can, that's the end of this chapter, so you can also now work through the mixed exercise 4, which starts on page 104. Now, there will be tutorials from all of your teachers available throughout this next week, as we've said on email. Your teachers should arrange those tutorial times with you, so please keep checking your emails, keep checking Show My Homework as well, because they might send the information out on Show My Homework, because it's easier to send that out as a class message. But yeah, if you've got any questions, please make sure that you log on at your tutorial time, and we will be there waiting. Okay, I'll see you soon.